Hello all. Now we are going to discuss about a case study regarding the green adsorbents for wastewater treatment. With a small introduction, what is the importance of this case study? So in this, we know that the textile and electroplating industries use certain organic chemicals, dyes, and also in inorganic chemicals which contains some toxic elements like chromium, cobalt, arsenic, etc. So these cannot be left as such as an industrial effluent into the river or to the land. As per the government norms, it should be treated and the level of these chemicals or dyes should be less than the prescribed thing so that it will not affect the environment. So these industrial plants must treat these effluent before they let out of the industry. So for this, they use many methods. One of the fine useful thing is activated carbon. So by using activated carbon as an adsorbent, so they are used to absorb these chemicals, particularly the dyes and the toxic metals. So by using this activated carbon is a costly affair for them because it cannot be recycled. Nowadays the activated carbon is been recycled several times in a particular study they indicated, but even though the activated carbon which are manufactured in the laboratory is a costly one, but in this case study we are going to discuss this thing particularly to reduce the cost of the activated carbon. So what they're doing, how can we do that, and what the industries are nowadays doing, and how the adsorbents are effectively working. So we need to look into an alternative adsorbent, particularly a green adsorbents. So what is a green adsorbent and what is its importance? So one of the serious environmental problem, as I said, is an hazardous and toxic pollutants in the industries. So wastewater contains some pollutants such as dyes, heavy metals, phenols, pesticides, and pharmaceutical chemicals. So adsorption is considered to be one of the most promising technique in the wastewater treatment for the last decades. It can be treated well and also an easy method can be applied in industries. A primary goal of this case study, its investigation, is the removal of different pollutions by using an adsorbent material. So the pollutants, not only it's a liquid, it may also be a gas one, like air pollution. The carbon dioxide absorption can be done by using a particular adsorbent. So even in the air or in a liquid medium, so we are using a solid adsorbent. These adsorptions are absorbing the pollutants so that the treatment can be an effective one. However, the adsorbents are used are not same. There is a development. Nowadays, the adsorption is not same one which we used 10 years or 5 years before. So the change of an under removal of a pollutants, particularly the discovery of a new synthetic dyes, it created a challenge to identify a good adsorbent to remove those things. So more faster coloring dyes, brighter dyes which can be applied to the fabrics. These are coming out of the effluent can affect the environment. So the effluents coming from the industry, particularly the textile industry or electroplating industry, they contain some anionic dyes. The textile industry's dyes can be classified like this: anionic, cationic, and non-anionic. So non-anionic is a dispersed dye, and cationic are basic dyes, and anionic are acidic dyes that can be directly applied to the materials. So, due to the increasing stringent restrictions on these effluents, so a wastewater should be properly discharged, and before it would be properly discharged. It should be treated well before it discharges. So many of these dyes are toxic, and some are carcinogenic in nature, and this possesses an hazardous effect to the aquatic living organisms in the ponds, lakes, as well as soil, etc. So, however, these wastewaters can be treated. It's very difficult to treat without a heavy investment, but nowadays there are several methods have been adapted to treat it. So the dyes are very resistant to anaerobic digestion. A new method of treatment is to be applied. That is an adsorption technique. The adsorption technique is the most popular one, and also a stable method to remove the pollutants. So dye adsorption is a result of two mechanisms. One is an ionic change process, another one is an adsorption process. An adsorption process is just a physical chemical process in which due to the van der Waals force of attraction between these materials and an adsorbent. There are two, one is physisorption and chemisorption. So mostly physisorption has been applied for the adsorption methods, and the ion exchange method, which we need to use an ion exchanger or a membrane to exchange the materials. So there may be a dye adsorbent interaction, so that the adsorbent absorbs the dye materials. The adsorbent's surface area, with the decrease in surface area, more adsorption can be possible, so that the particle size should be reduced and the optimum temperature to be maintained, and pH and the contact time also to be standardized, so that to get an better absorption of these chemicals. So the main advantage of this adsorption is nowadays is from the last decades it has been changing. We are using a costly adsorbents, that is activated carbon. Nowadays we are going to switch over for a cheap adsorbent, so that we can reduce the cost of the process. So in this case study particularly, we are going to think about what are the adsorbent which can be used so that to reduce the cost of the effluent treatment, and particularly we call it as green adsorbent. Then how effective it was, and it is based on some studies. So after the economic crisis, the researchers trying to reduce the cost of this process. So a possible way is to treat the things with an efficient activated carbon, particularly from the waste materials. So there are several papers have been published regarding this. The chart, the bar chart explains that published works based on the dyes is more than 5,000, and based on metals, phenols, pesticides, drugs has been discussed. But here our main concern is about the green adsorption methods. So the selection for most appropriate adsorbent would be based on some characters. That should be low cost, capacity to be reused, and industrially it should be applied again and again, so that we can reduce the cost. And another one is economic friendly. So by fundamentally it should be environmental friendly. I'm sorry about this. Environment friendly. So environment friendly, that means it should give some low impact over the environment. It should be degradable, and it should be obtained from the natural resources, and a non-toxic thing. So green adsorption. What is a green adsorption? So this new term introducing. uh, in this case study. The green adsorption is an activated carbon or adsorption material which has been obtained from agriculture resources and the byproducts of these agriculture things, fruits, vegetable foods, and from agriculture residues and waste from the agricultural land. It is a low cost source uh, which is produced from agricultural wastes. Particularly, we can prepare the activated carbon uh, by the agricultural sources by method of pyrolysis, that is heating to a high temperature and mixing with some acidic substances to create an activated carbon. So what is a green adsorbent? So green adsorbent will be expected to be inferior than the super adsorbents. Super adsorbents are adsorbents which are prepared by chemical methods like a silica gel, inorganic material, and modify cytosans, activated carbons, structurally complex inorganic compounds. Yes, they are expected to be somewhat little inferior, but their cost potential makes it very, very competitive. So in this diagram, you can see that the green adsorbents have been manufactured from the various agricultural products. What is the adsorption capacity of this one? Green adsorbent. So the adsorbent material, by its absorption capacity, it can be measured. This done by an experimental method with the data provided by Langmuir equation, or deriving a curve or a graph based on this Langmuir and Freundlich, and also a combined form of Langmuir-Freundlich equation of isotopes, LF equation. So what is Langmuir and Freundlich explains? So Langmuir gave a graphical method to analyze the capacity of adsorption. That is, they related the adsorption ratios with the pressure. So when they increases the pressure, the adsorption goes on increasing at an optimum pressure and temperature. There is a saturation point. After that, there is no effect. So after the saturation point, the graph becomes flattened. Mainly it increases and it becomes flattened. So what it indicates, after a certain limit of pressure and temperature, the adsorption becomes a straight line. Further, no absorption increases. So the adsorption depends upon particularly the pressure. So adsorption capacity of the adsorbents, that is green adsorbents. So there is a green material, we are taking it, making it into a powder, and we are making it in activated carbon, and the activated carbon has been filled in different columns as indicated in this. And after supplying the effluents to that, we are analyzing that those one in the lab. We can identify that how much adsorption taking place in that. So we can efficiently measure which green adsorbent will become a better one to treat these effluents, particularly what type of chemicals, usually phenols, pesticides, and chromium, etc. So we can select an adsorbent materials with this green adsorption and can analyze in laboratory. So how these green adsorbents will be effective for dyes? Example, a methyl blue is a commonly dye used in wool and silk industries. Okay, so it causes some serious injuries, effects to human beings and animals when it let out into the river or land. So inhalation of these dyes also produce some irregular effects like vomiting, profuse sweating, mental confusions, and methemoglobinemia, etc. So these dyes, interestingly, it should be treated effectively. So the first common one is that we by using an green adsorbent, particularly from the agricultural waste, the green adsorbent has been absorption from the green adsorption is being measured by QM, that is adsorption coefficient, is over 150 milligram, while some other has been extremely low capacity, less than 15. So the green adsorbent effectively works better for observing these particular type of dyes. So this statistics gives it is an effective one for using to remove the green dyes, these blue dyes, particularly these methyl blue dyes. So there is a variation. So next, by considering metal ion, the interesting work has been done by several researchers that green adsorbent, particularly from the agricultural waste, have some equilibrium data from LF curves, that is Langmuir-Freundlich curves. The adsorption value is found to be 79.4, 114.9 and 71.4 milligrams. So it slightly better absorption than certain ion exchange materials respectively. So this metal ion, particularly heavy metal ion, is a very important one, chromium, cobalt, like that. So, and up to now, a volume of adsorbent is collected and analyzed with an atomic absorption spectroscopy and also a plasma mass spectroscopy. There is no special need to measure the heavy metal concentration with some ashing produced into a material. So these methods indicates that some adsorption taking place to remove the toxic metals, particularly chromium. Chromium is a very highly toxic material from the industry's waste and also from the electroplating industries. But we don't need any method because adsorbents usually absorb the materials well. And there is another idea here. An example like in citrus hystrix, there is lime peel extract. The lime peels can be taken and made into a powder, and it has been mixed with some absorbing materials, so that this reduces. See, the first one, the graph shows that there is a reduction. In the beginning, the dyes are very high. So see the adsorption in the beginning, the adsorption is very very low. But after this one, the reduction in the dye, that is dyes are observed in a much more effective way. The green reduction of graphene oxide using a lime peel extract. It's one of the natural adsorbents used to remove the dyes, particularly methyl blue dyes, as we are talking about. There are some other ideas. Phenols is also an important pollutant that can be easily removed by green adsorbent. One of the studies based on a 2-chlorophenol by coir with carbon, that is the material which we make into a coir, that can be taken and it is been made into an activated carbon that has some very better absorption in removing the 2-chlorophenol. And when we go and fit with the Friedrich or Langmuir or Dubinin-Rosniak equation, Only the equilibrium adsorption capacity was presented and not the theoretical maximum one for a modeling. So the modeling can be done, but before modeling, the theoretical thing plays a better role to analyze this thing. Other ideas, there are some other ideas based on this one. That's particularly the work done by L. Bekowi and his co-workers, that they used acid treated olive stones, so green adsorbent, in order to remove some pesticides, aldrin, dieldrin and endrin, with low adsorption dosages. And this QM value for these things was better. The removal of a particular pesticide, that is paraquat, was also expanded by them by using a rice husk material, also a better adsorption. And for the modeling of this adsorption, we can go and try for kinetic methods. The modeling can be done with the kinetic method, that is the rate of the reaction with respect to time. So by this study, we can identify that how much adsorption is taking place when time proceeds. So we can say for a quick adsorption, we can discuss for a quick adsorption materials or a very adsorption which has some low timing, can also be identified with the mobile phase of a liquid, and we are making an the mobile phase may be a liquid, that is effluent, or the air which contains pollutant, and the stationary phase may be taken as an activated carbon. So by this we can model a graph with Langmuir or a Freundlich, so that we can fit this experimental data in this modeling and we can identify which one will be a better thing. There is a techno-economic analysis and future aspects of this green adsorbent. I've been talking previously. The activated carbon. The world demand for virgin activated carbon has been forecasted that 5.2% per year from 2012. Now the requirement is 1.15 million metric tons to remove these dyestuffs. The consumption of the activated carbon for industrial use have now been an indicator of development and economic management efficiency. The per capita consumption of activated carbon per year is 0.5 kilogram in Japan, particularly to remove the things from the industrial effluents and air. And USA is 0.4, less than the Japan, and Europe it is 0.2 kilogram, and rest of the world is very, very low. India also, we need to develop research in this area so that we can reduce the effluent treatment cost. And there are also another some doubtful things which is present in this particular topic. That means we have to analyze again and again an adsorption capacity for the particular adsorbent. Not all the adsorption have the same adsorbing capacity. We don't model one or we don't apply a certain model to another one. So each and everything need to be analyzed and researched. So the kinetic model should be set based on experimental data, and optimum condition should be defined for each and every green adsorbent. And another one is the data of a green adsorbent process to be expanded from laboratory to industry. So in India, the green adsorbent has been have been using only in the laboratory. We are producing some research ideas, we are reporting something, and it has not been expanded into the industries. So our main concern of this case study is these things are happening, so it should be expanded and applied to the textile and electroplating industries, which there is a need to treat the dyes and heavy metals. So again, in the conclusion part, we can say that there are three isotherm models. You know that Freundlich, Langmuir, and combined Freundlich and Langmuir absorption. So based on this, every cases has to be studied with the green adsorbent, and there are also some models have been developed recently by Lagergren, pseudo second order equations, along with Ilovich. So these things of a kinetic study regarding the adsorbent to be expanded for to get a low cost adsorbents applied to the industries for a safe and secure environment and effluent treatments. Also, chemical reaction engineering approach and an ordinary differential GREA, that is a chemical reaction engineering approach. We can also say it is GREA, green chemical, or CREA, chemical reaction engineering approach, or we can say green chemical reaction engineering approach in an ordinary green adsorbents to fit to an experimental data to be applied in an economical aspect. So techno-economical analysis was also done comparing the directly a green adsorbent material with a non-green one. The things have been reported by comparing the green adsorbent and non-green one, but our concern is to develop the techno-economical aspect to produce a better adsorbents. So the main conclusion is the superiority of the effectiveness of a green adsorbent regarding the chemical super adsorbent should be identified so that we can treat the effluents effectively. So we can go for these references. Thank you. And another case studies we can discuss about modeling and other aspects. Thank you.